Westinghouse Award.
He's always known as being really brilliant, and he's remained so. He's done really remarkable research. I am not going to show you my grades from college, especially my chemistry grades. Not really something to show in mixed company, or in any company for that matter. I think what really unites us is the fact that we are excited about what we do and willing to put up with the frustrations of having experiments sometimes not work for us. I think it's really the passion that really unites us. I think that the story of GFP, especially not only Shimamura's work with the jellyfish, but also the fact that I didn't fall asleep in that seminar, a very good thing, is that many, if not most, discoveries in science are actually accidental. In fact, the physicist Enrico Fermi has a wonderful line, which I'll probably follow up and not really quote completely, but it goes something like, if you do an experiment and it confirms your hypothesis, then you've made a measurement. But if you do the experiment and it doesn't confirm your hypothesis, then you've made a discovery. We really do need to have more of the discoveries. You do actually need both, the confirmation, more data, and also being able to find those unusual things that happen. I think it's important to be either ignorant or stubborn or just willing to try things even when people tell you they're not going to work. Just try the experiment. In fact, there's a really long tradition in biology and probably other sciences but it has different names depending on who talks about it. It's either called a Saturday morning experiment, some weekend thing, Saturday afternoon, Sunday morning, Sunday afternoon experiment. Now what this experiment is an experiment that you do on the weekend because no one else is there. You've snuck into the lab and you've tried this crazy idea that you're absolutely ashamed to let anyone know you have. And you try the experiment, and if it works, you crow about it on Monday morning. You're just full of yourself. If it doesn't work, you ask people how their weekend went. So it's really important to try these things. I think the other thing about the GFP story, starting with the Nobel being given not to one person, but to 3 people, and really extending to all the people that have used in GFP, is the reason GFP is important is not any of the 3 of us, but really all the people that have worked on GFP. The scientific progress is really cumulative. It's all these little added bits that people have put on it that other people then use to make it better. In fact, I like to think about GFP as a metaphor for what we do in science and how science is conducted. Because just as GFP absorbs light of one wavelength and modifies it, gives it off as light of a different wavelength, we as scientists take in results and experimental data from other people, modify it by our own ideas and experiments, and then give it off in turn to be modified by someone else. And GFP is a very good example of something that's been modified repeatedly over the years. To me, so the next point is sort of not so much a thank you, although it'll sound like a thank you. It's really something that I feel is very important. And that is that I don't think I could do this work if I were not in a university and with federal grant support. I want to point out 2 things about this. Being at a university, the university, sorry to say this, they don't care what I do. They just want me to succeed. They just want me to come up, to make discoveries, to get results. But they don't tell me what to do. No one tells me what to do, and I already said I don't like to be told what to do. But the success, if the line of experiments work, then I'm going to be able to renew my grants. If they don't work, then I'm in trouble, right? So I have to keep working and doing things. But I'm the one that decides this. For me personally, being in industry would not give me that freedom, because in industry, a lot of times, if a line of experimentation doesn't go with what the company wants to do, it can be very exciting, but it's stopped. I find that uncomfortable. I can't do that. Having the university as a place to be able to do research, I find exceptionally important. The aspect about the grant, I think, is very important, especially to tell non-scientists. Because I think people mix up the idea of a grant and the idea of a contract. When we write grant proposals and say, here's the 5 items we're going to do, our 5 specific aims, we're not doing a contract. We're not saying, if you give me this money, I'm going to do items 1 through 5. What we're really saying is, at this point in time, these are the 5 most important things that we should be doing. And that's what I want to support. But there's also this sort of tacit line that then follows that nobody ever says, and that is, however, if in 2 months from now, I discover a new method or a more exciting project, I'm going to use the money for that. And you're going to be grateful that I did, because I'm going to make greater headway on that. It sort of gives you the freedom. On the other hand, at the end of the 3 or 4 years or 5 years that you have the funding, you've got to justify that you used the money wisely. But it's not a contract. We're not saying, I'm going to do this. In fact, we would be idiots to say that. Because by 5 years, everything changes. And it's just the way science goes on. It always is changing. So the next point I want to make comes not only from observations in my own lab, but from what happened when we started giving away GFP to people. They call up. Usually the head of the lab would call me up. And almost invariably, they had the same first sentence. 2 slight variations. One variation was, my graduate student told me, or it would be, my postdoc told me, that you have something called GFP. Tell me what it is and tell me why they wanted me to call you to get it. And I'd explain it to them, and they'd say, they're absolutely right. Yes, we want it right away. Here's our FedEx number. Send it to us immediately. And that gave me this idea, as I say, also looking at people in my own lab, that the people that are really the innovators in the labs are the postdocs, the graduate students, and the undergraduates that are contributing to the science, because they're the ones doing the experiments. And often they're the ones talking with one another and getting new ideas and bringing them to the research. So it doesn't make any difference what level it is. It's the person actually doing the experiments that's really important. 2 more points. The first one is that I hope that you've gotten from this story about GFP, especially Shimamura as part of this, that we really should be studying all organisms, many more organisms, and not just the few that we've picked as the so-called model organisms to study human biological problems or human disease. Those are clearly important. I'm not saying we shouldn't study those, but we should broaden our horizons to look at many more organisms and how they work, and to try to understand them. We should be studying all of life. And my final point of why I think the story of GFP is really useful is that the problem that Shimamura wanted to address was a fascinating biological problem, not a health problem, not a human problem. He wanted to know why jellyfish and other organisms were capable of producing light, bioluminescence. Which go to the Natural History Museum, you can see the show on about that. So he was interested in this fundamental biological problem. Out of that came this, actually 2 remarkable molecules. Boron was the first calcium sensor that people used in cells, and GFP, as I've tried to show you today, has done a lot of things too. So I think the important part is that basic research is really essential. And it, in fact, is what drives innovation in the study of human health and advances in agriculture and in industry. That we need to have the basic research. There's a big push these days for what's being called translational research. That is, that we take the observations that people have made in the basic research laboratories and apply them to human disease to try to formulate cures or ways of preventing the disease. Especially as I get older, I like this idea a lot. good to have translational research. My problem is it's not that I don't want translational research, I very much do. I think it's important to have a balance. Many people have said, if you want to have translational research, you have to have something to translate. You always need to have this basic research pipeline giving us new information, whether it's about RNA interference or microRNAs or GFP or any of these things that add to our knowledge so that we can start to think about these problems in more sophisticated ways. We need to have the basic research for this. And so with that, I want to leave you with a quote, one of my favorite quotes. This is from Robert R. Wilson. Robert Wilson was the first head, actually the architect, of the Fermi Lab, the particle accelerator at Batavia, Illinois, that until about a year and a half ago, when the CERN accelerator came online, was the largest particle accelerator in the world. In 1969, as he was designing it, he was asked by Congress to come and justify, and they had a joint session of a committee, Science and Technology Committee for the House and Senate, and they invited him to come and testify of why the Congress should pay this enormous amount of money for this particle accelerator. By the way, in what might be a completely unheard of turn of events for a government-funded entity, he actually built it ahead of time and returned money to the government. He was very efficient. He also did interesting things too. There's a thing that's now called the Wilson Tower on the site, and it has a wonderful observation deck that you can see all the surrounding area. And he designed that building based on going on a helicopter ride. He hired a helicopter. He got it to the site, and he said, "Keep going up. That's the right height. That's the view I want people to have." And that's how we did it. He said, "What's your altitude?" That's how he built the building. Very interesting guy. But at this hearing, John Pastorian, the senator of Rhode Island, said, who was in favor of the project, thought he would throw him like one of those easy questions that can be absolutely snapped up and convince all his colleagues to vote for this thing. And the question was, Dr. Wilson, can you tell us just how many things will benefit the national security that will come out of this lab, this laboratory, this accelerator? And Wilson looked at him and said, "None." Pastori pushed him a little more because that was not the answer he wanted to hear. And he kept saying, "No, really, how? None." And then finally he said, Pastori asked him, he said, "Well, look, in what respect will this help the national defense?" At which point, Robert Wilson said, "It has only to do with the respect with which we regard one another, the dignity of men, our love of culture. It has to do with whether we are good painters, good sculptors, great poets. I mean all the things we really venerate in our country and are patriotic about. It has nothing to do directly with defending the country, except to make it